Hello, my name is Johnny Ray Cornell Jr. and I'm making this video to talk about where the electron comes from in beta decay that goes to the Bohr radius and is the proton's ground state electron after beta decay. First of all, my thought processes are, where does this electron come from? How is it produced? And what particle? How is the particle formed that it's produced from? And there's no way you can talk about beta decay without talking about the down quark. And the down quark is a leptogluon. The down quark is a leptogluon, and this is what the down quark looks like. It actually looks like this. These strings are what we talked about in our last video. And yes, these strings right here, these strings should be drawn in circles too, but I just drew them in lines. They're produced out of the same strings as the electron we talked about in our prior videos, how the strings bond to form the electron. The strings in a lasered, perfectly combined waveform, a lasered, perfectly combined waveform of gamma produces the gluon from a waveform that looks like this. What happens here is, this is the strings in the waveform. You follow the waveform, and this is another waveform, and this is another waveform. I got to train you how to look at this. And this is another waveform. And all these waveforms are lased together. And these waveforms are the same frequency. They're the same frequency. Because this is what it looks like coming directly at your eye. They're not lased, they're not coherent like this. They're coherent like this. One travels like this, and another one travels 90 degrees to it. The other one travels 45 degrees to it, and the other one travels 22.4 degrees, 22.5 degrees from it. So what we have, the gluon, this is the part of the waveform. This is the part of the waveform that produces a gluon because it's stacked, and the weak force bonds it right here at the poles. And once it's bonded, this structure starts spinning. If it spins right, it's positively charged by convention. If it spins left, it's negatively charged by convention. And this 8-string gluon beta decays into the down quark, which has a 6-string gluon and two leptons attached, a positron and a electron. Now, that needs to be talked about. They're bonded by the weak force, and they won't annihilate the leptons. They annihilate in pair production, but that electron has got to come from somewhere, and that's the only way in nature, unless the down quark produces a gamma that would pair produce a pair of electrons, and something steals the positron and it is converted into a neutrino, and that's where you get the neutrino in beta decay. But the only way to get rid of that positron is it's converted to the neutrino, and it's done electromagnetically, and we're going to talk about that in this video and in other videos, because that's a complex thing, and I have no math based on it, and I need experimental access to experimental tools I don't have at the moment to gain the math, to get experimental mathematics, because that's the only way you're going to get math. You can't get it from any other mathematics on this, because there is no way to tell. And now, let me explain that further. If the gluon spins to produce its charge, and its spin also produces the strong force, the gluon is the only thing, the free gluon without a lepton attached, just a free gluon, is the only thing in nature that will unify the forces, because it has the strong force it produces by spin right, spin left. Who knows if it spins right or left to produce the strong force, because the strong force pushes and pulls, but you got chirality problems in spin, because if it's spinning one way and it orients itself another, like take a roll of toilet paper and put a dot on it and spin it and keep spinning it in the same direction, and that dot will go up. I'm going to do this experiment on here and show you too in another video. I didn't think about this. This is a chirality problem. If you take a roll of toilet paper and you put a dot on it and you turn it, and that dot is going up, well, as you if you keep turning it the same direction, but turn the toilet paper roll all the way around, the dot will then be going down when you're spinning in the same direction. So that may have an effect on generating forces from the gluon that is immense. And the spin of the gluon generates the strong force. And electromagnetics, and it is held together by the weak force. It is held together the same way the electron is held together by the strings, and the strings that bond on our two or three postulates. I haven't found out which ones are pure postulates and which ones I can base mathematics on yet. I'm still going over that. But there's two pure postulates I know of, and that is that there are three. They're closed loop strings, and instead of expressing their identity and energies by waves on the string, on the circumference, they're rigid and they spin right or they spin left. And they generate a charge called the weak force. And they bond to form larger structures. The electron is one single electron string that spins. It's a bunch of the smaller strings bonded together through their fields, like electromagnets would be bonded together if you laid them out on the floor, round ones. and stuck them all together. So, and I've done that, and you can actually pick up one side of it with two hands and it'll stay together. I would imagine if you held it up and had it strong enough to where you could spin it and it would stay together, would it generate a field in space? I don't know. That needs to be looked at. That really needs to be looked at. I think it would generate a field. I'm not sure. Anyway, I don't know if that's experimentally been looked at before. It probably has in time somewhere, and they probably junked it, not thinking it was anything usable. Well, anyway, the one thing I want you to really take away from this video is the gluon spin produces the strong force, and one side of the gluon, the free gluon without a lepton, a quark, a leptogluon is a quark, just a free gluon. One side of it pushes, one side of it pulls. The strong force pulls. And in quarks, the gluons only pull, they don't push. They never push. Thank you.